Let's do another simple one here. How about the derivative of y equals e to the 3x? E to the 3x. For exponential functions, what do you do to find the derivative? You copy and paste, so it'd be e to the 3x, but then you have to remember to multiply times the derivative of that exponent. So the derivative of 3x is 3. So if I clean this up, I'd have y prime equals 3 e to the 3x. So that's how your chain rule works with your transcendental functions thus far. Let's go ahead and look at this next problem. It says parentheses in trigonometric functions. This is example 11. And what it's trying to emphasize is it's really, really important where those parentheses are. So it says find the derivative of the following functions. Well, textbooks often get lazy and don't put parentheses where they should. Don't put parentheses there if they're when they're necessary, okay? So what's the derivative of y equals cosine of 3x squared? Well, we already said the derivative of cosine of u is negative sine of u. So this would be negative sine of, keep the exact same thing, which would be 3x squared. But then you need to multiply times the derivative of the inside. So we're looking at the derivative of 3x squared. The derivative of 3x squared is 6x, and remember that belongs on the outside. So I would have what? A negative 6x times the sine of 3x squared. I almost always put those parentheses. The book very, very seldom does. So negative 6x times the sine of 3x squared. Okay, let's look at the next one. The next one is cosine of 3 in parentheses times x squared. And what I want you to notice is this part right here, this cosine of 3, that's just a constant. We don't have a variable. Cosine of 3 is a number here. So this is a constant multiple. So if I want to find y prime, that's a constant multiple. It stays there. Cosine of 3 times the derivative of x squared. Well, that's just 2x, right? So what am I getting? I'm getting 2 times the cosine of 3 times x, whatever the heck that is, okay? I have no idea what that is, but that's what it is. It's a number. You'd put it into your calculator in radian mode, and you would get your answer, 2 times cosine of 3 times x. Let's look at the next one. How about the cosine of 3x squared? So what they really mean here is the cosine of 3x quantity squared, which I'm going to go ahead and square that. So this is really the cosine of, because it's multiplication, I can distribute that square through. This would be the cosine of 9x squared. Okay. So what's the derivative of cosine? Well, we know the derivative of cosine of u is negative sine of u times u prime. So that would be negative sine of the inside, which is 9x squared, but never forget to multiply times the derivative of the inside. Well, the derivative of 9x squared is what? Would be 18x. So if we clean this up, I'm getting a negative 18x times sine of 9x squared. Negative 18x times sine of 9x squared. Okay. How about y equals cosine squared of x? Remember, if it helps you, rewrite this as y equals cosine of x quantity squared. So when I find the derivative, I actually have to use the chain rule on this. I drop the power, which would be a 2. Cosine of x, keep the inside exactly the same, raised to the power minus 1, so that would be the first power. But then we need to multiply it times the derivative of the inside. So I need to multiply it times the derivative of cosine of x. Well, the derivative of cosine of x is negative sine of x, right? So in simplifying this, what do I have? I would have negative 2 cosine of x sine of x. Negative 2 cosine of x sine of x. Okay, let's look at the last one on this page here. It's y equals the square root of cosine of x. So again, I'm going to rewrite this as cosine of x raised to the 1/2 power. So what do I do to find the derivative of that? I drop the power, so 1/2. Inside stays the same. This would be cosine of x raised to the power minus 1, so that would be negative 1/2. But I have to remember from the chain rule to multiply times the derivative of the inside. Well, the inside is cosine of x, and the derivative of cosine of x would be negative sine of x. So I'm going to clean this up. I'm going to do a lot of steps in one. On top, it looks like I have the negative sine of x. And on bottom, it looks like I'd have a 2, and then dropping that cosine of x into the denominator would be cosine of x to the 1/2, which is the same thing as the square root of cosine of x. So what I'm getting is negative sine of x over 2 times the square root of cosine of x. Negative sine of x over 2 times the square root of cosine of x. And there it is.